How ARP works. ARP uses broadcast communication, one-to-all, in order to ask all end clients within a LAN, what is the physical address of a given IP? ARP messages. There are two main types of packets in ARP. Operations. ARP request. ARP reply. Figure 2 shows an example of both types. You can see that there are 4 fields in the ARP header: source hardware address, MAC, source protocol address, IP, target hardware address, MAC, target protocol address, IP, ***. Note that in the ARP request message, the destination MAC address is the well-known broadcast address FFFFFFF. This signals the switches in the LAN that this is broadcast communication, and all connected devices in the LAN must receive a copy of the frame. The other important value to note is the target MAC key is 0000000. This signals the owner of the target IP that the sender is trying to resolve the physical address of this IP. Note that in the ARP reply messages, both source and destination MAC addresses are unicast ones. ***. There are 4 typical cases when this happens. Host wants to send data to another host in the same network. For example, PC2 sends a message to PC3. PC2 sends an ARP request about the IP address of PC3, 192.168.1.3. Everybody on the LAN receives a copy of the ARP frame. PC3 replies back with its physical address BBBBBBBBB. All other hosts drop the ARP request. Host wants to send data to another host in another network. For example, PC2 sends a message to google.com. PC2 looks at its routing table, finds the IP address of its default gateway, 192.168.1.1. Sends an ARP request about the default gateway IP address, 192.168.1.1. Everybody on the LAN receives a copy of the ARP frame, including Router 1. Router 1 replies back with its physical address receives data destined for a host in a locally connected network. Router 1 receives data destined for PC2. Router 1 sends an ARP request about the destination IP address, 192.168.1.2. Everybody on the LAN receives a copy of the ARP frame. PC2 replies back with its physical address. All other hosts drop the ARP request. Router receives data destined for a host on another network. Router 2 receives data destined for PC2. Router 2 checks its routing table, finds that the next hop address towards PC2 is 34.43.12.1. Sends an ARP request about the next hop IP address 34.43.12.1. Router 1 receives a copy of the ARP request. Router 1 replies back with its physical address. Add 12-43 EBI-F432. ARP table, ARP cache. When a device successfully resolves the MAC address of a given IP, it stores the IP to MAC binding in a table called the ARP table. Subsequent communication used this cached binding instead of sending ARP. Request out again. * Each entry in the table is kept for 240 minutes, 4 hours, by default. This value is known as ARP timeout and can be set to a different value per interface. You can check it by a look at the output of show interface. ***. The ARP cache of hosts running Windows or Unix can be checked by executing ARP A in the command prompt window.